The first highly Pythonic concept that we're going to talk about are these things called Lambda Expressions. These are like small inline methods that you can pass around, chain together, and build larger expressions from. Let's look at the idea of using functions as a parameter in the first place. So here we have find special numbers. Now this function is just going to go through some set of numbers. It's kind of hokey, I know, but it's going to loop through a bunch of items. In this case, the numbers between 0 and 10. And it's going to apply our selector. So special selector is a function that takes a number and returns a Boolean. So we can call the function, pass it a number, and it'll say this number should appear in our list, or maybe it won't. Now this method might look for even numbers, it might look for Fibonacci numbers, it might look for prime numbers. I don't know. That's the point. We can pass whatever type of function we want in here, and the selection part will be done by that function, whereas the gathering and looping part will be done here. So let's look at this idea in Python. So down below we have our find special numbers, just like you saw in the slides. And I've written this other function called check for odd. Right, you can see it's doing the standard modulo check for odd numbers. So we can come up here, we can combine these two things together, like so. We can say for n in, we can say find special numbers, and this takes some kind of selector. And so I can say check for odd. Now, PyCharm automatically tries to call this function, but I don't want to call it. I want to just pass it. All right, we'll see that if I take this and I actually print out this here, maybe I'll even do the type for you. Do the type and then the actual value of it. We'll see that this comes out as a type of function and a particular function pointer to a particular type of function. So just like any reference, we can pass it here. Maybe we want the first, 50 numbers. We'll just print those out. And let's print them all in one line so you can see them. So we use a separator of comma to just comma separate these values. So let's run this. Perfect. So you can see we got our prime numbers here, including the first 50 prime numbers that we were looking for. And also see where we printed out our type of check for odd, we got the type as a function, and it's a particular function check for odd at that address. So that's cool too. Now this works fine, but writing this check for odd function down here, every time I want to be able to pass a function around, this is kind of, well, odd. So it works fine, but it separates the implementation from where we're using it. And if the implementation is really, really simple, it can clutter up your namespace with all sorts of little functions, and it can move where you're using them from where you're defining them, so it's a little harder to understand what's going on. Let's take this basically the same idea here, and maybe so it doesn't shoot all the way off the screen, we'll lower that number a tad. And we can come down here and we can say, I want to do the same thing, but this time I want to check for numbers divisible by 6, and I want to use a lambda. So let me just write it on a separate line first. We'll call it check equals, and then we could pass the check, just so it's more clear. So with the lambda expression, I would like to just say, given some number I would like to somehow say return I mod 6 equals 0. Right, now this obviously is not the right syntax. Given this, I don't know, somebody want to specify this value goes here and just sort of pass this little bit of code. So in Python, the way we say we're defining a lambda is you say lambda and then the arguments, the parameters, and you say colon as your separator, as you normally would. Every lambda has a little expression of value it creates and it returns, so you don't say the return value. So there, this is our lambda expression. Now if we run it, it should work. Perfect, here are our divisible by 6 numbers. So it works. But PyCharm here is saying, not so much. PEP8 says don't define lambdas outside of their actual use as pointers. Rather, we should do a little miniature def here. So let's inline this as it's kind of meant to be used. There. So we can just take our lambda expression and pass it as a parameter. And that's what lambdas are for. You can create these little expressions that you can chain together, pass as parameters, and so on. So we should get exactly the same behavior if we run it. And we do. Cool, so if we have to just come up with these little bits of code here and pass them around, lambdas are beautiful for this. Let's look at another example. So here I have a bunch of words, and I would like to have them sorted. I'd like to have them sorted in a way that regular people would say, yes, those words are sorted alphabetically. So one way you might say, let's give it a shot, is we could just come here and say words.sort. Now, whether I use sort or I could say sorted, these will both generate sorted lists that I can then go and work with. The difference is this changes the underlying list of words, whereas this returns a new copy of it that is sorted. So it doesn't really matter. We'll go with this one for now. So let's try a sort like so and see what we get. Okay, C Python please a and changes. Well, these look sorted and those look sorted, but as a group, they don't look sorted to me. That's because right now the sort is case sensitive. Okay, well, what do we do? Are we just out of luck? Do we have to write our own sort algorithm? No, of course not. So what's cool, let's comment this out because that almost works, but not quite. In both versions of sort, they let you specify a key selector. And what this key selector is it's a function that given one of the items, in this case a word, we can return something that we'll actually use as the sorting value, the comparison value. So we could put a function here, but I'm going to define a lambda expression. So I'll say lambda w for word goes to, well, if we just put it like this, w, it'll do the same sort, but I actually want to sort without regard to the case. So let's do this. Let's say lower. Anytime you want to compare a word, don't compare the actual word, compare the lowercase version. We could use upper, so on. Let's try it. Now look at that. That looks sorted, doesn't it? And look how incredibly easy this is. Key equals lambda w colon w goes to w dot lower. That shows you some of the power of lambda expressions in Python. Let's look at that in a graphic. So here again we have our find special numbers. We also saw the same situation applies to built-ins like lists and so on. So we want to pass some kind of selector, and we could write a special method somewhere using def method name and pass it. But if it's a small little test, it makes much more sense to do this as an inline lambda expression, like so. So we just write lambda, arguments goes to return value basically. If there's no arguments, you just say lambda colon. You could have multiple parameters like any other method as well. Using lambda expressions is a very Pythonic thing to do. Thanks for watching. This video is just one of over 50 Pythonic techniques you'll learn in my full course. Check it out at talkpython.fm/Pythonic.